Okay, so this is the first of our videos reviewing quadratic functions in algebra. The first part of this chapter, which is chapter 3 in your textbook, we are taking to be assumed knowledge, so that's the expanding and factorising, simple solving using the null factor law, and relatively simple sketching from turning point form and from a expanded form. So I'll go through those videos here. The subsequent videos afterwards, the review of completing the square and quadratic formula and using the discriminant and solving quadratic inequalities. We'll go through that in a little bit more depth. Okay, so a quick review of expanding brackets. So, okay, we should be familiar with things like the distributive law, which is expanding brackets when you have just one term out the front, you know, ax plus ab. The double distributive law, when we have, you know, two brackets, x squared plus a plus bx plus a times b. And then also expanding out perfect squares, difference of two squares, and obviously collecting like terms are all important features here. Something like expanding brackets at this point in your maths education really is a fundamental skill, and it shouldn't be something that you need kind of 3 lines of working to do. Okay, so I really want you to focus on when you're doing some review of expanding brackets, that if you're expanding out something as simple as this, that you're not doing x times x is x squared, and x times negative 3 is negative 3x, and 2 times x is positive 2x, and 2 times negative 3 is negative 6. And then I can collect together these two terms and I can get negative 3x plus 2x is negative 1x, and I can be done with that. You need to work to a point where you can go straight to here, okay? It's going to be x squared minus 3x plus 2x, which is minus x minus 6, okay? And do a bit more of that in your head so you can literally just write the answer straight down. Similarly, looking for shortcuts where you recognise the difference of two squares, you recognise the perfect square, and you can do those expansions immediately. So again, you know, x plus a all squared, okay, yes, it's x plus a times x plus a, which is, you know, x squared plus ax plus ax plus a squared, which is x squared plus 2ax plus a squared. But I want you to be able to go straight from here to here. We haven't got time for this, okay? So you need to be able to recognise those perfect square patterns, okay? If it's a plus or a minus in here, it'll be a plus or a minus here, otherwise that will be the form. X plus a all squared will be x squared plus 2ax plus a squared, x minus a all squared will be x squared minus 2ax plus a squared, okay? Those sorts of things we really just need to be able to do very efficiently now without really thinking very hard about them. Okay, so let's work our way efficiently through these then. So the first half here we're going to use our distributive law, so it's going to be x times 5 minus x, so that is 5x minus x squared. Careful here about this subtraction, okay? You can think about that as it's negative 1 times this second bracket, so it's minus x and minus 1 times minus 2, which is plus 2. That'll be the error you'll make in this expansion. And then we just want to collect like terms. We've got negative x squared, 5x minus x is plus 4x, and plus 2. Conventionally, quadratic trinomial, write the x squared term first, then the x term, then the constant term. And no, you can't just multiply all that by negative 1. This doesn't equal x squared minus 4x minus 2. If this was an equation, if you were solving negative x squared plus 4x plus 2 equals 0, then an equivalent equation to that is this equation, because you've multiplied both sides of the equation by negative 1. But these two things aren't equal to each other. Okay, you've just made two equivalent equations, so it's really important that you understand that distinction. I find students frequently try to do that. Okay, question 2. We want to expand everything out here. We're going to have 4 times 3x is 12x. 4 times negative 1 is minus 4. Negative x times 3x is negative 3x squared. There's your x squared term. And negative x times negative 1 is positive x. Now, this was all in a slightly unusual order with the x term second here and lots of negatives, so I am going to write out the 4 terms and then collect them in this instance. So minus 3x squared, we've got 12x plus x, so plus 13x and minus 4. Okay, example 3 is an example of a difference of two squares. Well, it will expand to give a difference of two squares, okay? if you have a minus b times a plus b, when you expand that out, you get a squared plus ab minus ab plus b squared, sorry, minus b squared, because it's negative b times b. And those two middle terms always cancel out, and so it is a squared minus b squared. So we want to be able to recognise this pattern, same two terms in the brackets with a plus in one and a minus in the other, and go straight to the a squared minus b squared. So we've got that here, we've got 2x at the start of both brackets, 3 at the end of both brackets with a plus in one and a minus in the other. So straight away we want to see, well, this is going to be 2x squared minus 3 squared, difference of 2 squares. So that's 4x squared minus 9. X plus 5 all squared, so that's a perfect square. Again, we want to recognise our pattern. A plus or minus b all squared is a squared plus or minus 2ab plus b squared. So in this case, that's going to be x squared plus 2 times x times 5, so plus 10x plus 25. Look, yes, you can always write them out and expand them out fully, but the key is at this point in your maths learning, really your algebra should be at a point where you can pretty much do those expansions straight away. If it's not, you're going to be wasting too much time on these basics and not able to actually make progress with all the new content that will come in the next 2 years. So just some practice of expanding brackets. Once again, do what you need. Maybe, do a few of each kind just to refresh your memory. But if you need to practice some versions, a few more examples of some, then by all means do that. Really, again, focusing on efficiency here, really trying to be able to pretty much go straight directly to the answer. If you can't, by all means, if that decreases your accuracy too much, then write out an extra line, but you still need to work on becoming quite efficient at this.